Hello, good morning, everyone. I am Joy Bhattacharjee from Technocrat Institute of Technology. Today, I will discuss Introduction to Database Management. So, what is data? Data is raw facts and figures, and when we process the data, we get information. So, the outline of this class is the need for database, data models, relational databases, database design, storage manager, query processing, and transaction manager. Database management system DBMS contains information about a particular enterprise collection of interrelated data, set of programs to access the data, and environment that is both convenient and efficient to use. Actually, to replace the human memory, we use the database in our computer system. Database application where we can apply these applications: banking transactions, airline reservations, universities, sales. In sales, we use customers, products purchases. Online retailers use order tracking, customized recommendations. Manufacturing, production, inventory orders, supply chain, human resource, employee records, salaries, tax deduction. Database can be very large. Database touches all aspects of our life. We cannot think of a life without the database. University database example like addition of new students, instructors and courses, register students for course and generate class rosters, assign grades to students, compute grade point averages and generate transcripts. In early days, database applications were built directly on top of the file system. Drawbacks of using file system. What were the drawbacks of using file system that led to the database management system? Like number one is data redundancy and inconsistency, multiple file formats, duplication of information in different files, difficulty in accessing data, need to write a new program to carry out each new task, data isolation, multiple files and formats. We know that every file had a different formats. Integrity problems, integrity constraints like balance, when balance is greater than 0, becomes buried in program code rather than being stated explicitly. Hard to add new constraints or change the existing ones. Atomicity of updates. Failures may leave database in an inconsistent state with partial updates carried out. Example, transfer of funds from one account to another should either complete or not happen at all. This is called the atomicity of the transaction. Either the transaction will be completed or it will not be completed at all. Concurrent access by multiple users. Concurrent access needs for performance. Uncontrolled concurrent access can lead to inconsistencies. Like here example is given that two people reading a balance say 100 and updating by withdrawing money 50 each at the same time. This can lead to inconsistency in the database. There are also security problems. Hard to provide user access to some but not to all. Levels of abstraction. So abstraction is generally called as abstracting the essential details and hiding the unnecessary or unimportant data. Physical level describes how a record instruction is stored. Logical level describes data stored in the database and the relationship among the data. Type, like it is example, the instruction record. ID can be of string, name can be of string, department name can be of string. Salary we cannot store as a string. Salary should be in integer, like this. So every database has a three view: physical view, logical view, or the view level. View level is the external view which external users can see the database. How external users are seeing the database is can be called as external view. Application programs hide details of data types. Views can also hide information such as employee salary for security purposes. Now we go on to the view of the database, or can be called as level of the database. Like view 1, view 2, these views are generally seen as an external view or view seen by the application programmer. Logical view, how we can define the database. Every database has to be defined It can be called as a logical view or the conceptual view. Physical level is how we can store the database in the storage structures and how we can access from that storage structures. Instances and schemas, similar to types and variables in the programming language, we can map the view to the schema. Logical view can be mapped to the logical schema, physical view can be mapped to the physical schema, and like on. The overall logical structure of the database. Example, the database consists of information about a set of customers and accounts in a bank and the relationship between them. Analogous to type information of a variable in a program. Physical schema, the overall physical structure of the database. How the database is stored in the physical storage. Instance, the actual content of the database at a particular point in time, analogous to the value of a variable. Physical data independence. Now we go on to the independence. There are two types of independence: physical data independence and logical data independence. The ability to modify the physical schema without changing the logical schema. When we are modifying the physical schema or the storage structure, it should not change the logical schema. Application depend on the logical schema. In general, the interfaces between the various levels and components should be well defined so that changes in some part do not seriously influence the others. Now, data models. A collection of tools for describing data, data relationship, data semantics, and data constants. Relational model, entity relationship data model, object-oriented data models, semi-structured data model, other older models like network and hierarchical models. How we are organizing the data is called the model of that particular database system. Now we go on to the relational model. Like here you can see that all the data is stored in various tables like ID, name, department, salary. ID, name, department, salary is called the columns, and when we fill that columns by the record, that particular record is called a row. Like for example 2222 Einstein physics 95,000 is called the rows of the database. In database, rows can also be called as a tuples. Sample of relational database, you can see this is a sample of the relational database. Now we go on to the definition languages, database languages. So there are different types of database languages like data definition language, data manipulation language, and like so on. Specific notation of defining the database schema, like when we are writing the SQL query, create table instructor, ID character, name varchar, department name varchar, salary numeric. DDL compiler generates a set of tables stored in a data dictionary. So what is data dictionary? Data dictionary contains the metadata, that is data about data. When we are defining a data, and that meaning is stored in another data, that can be called as metadata. Database schema, integrities, constants, authorization, who can access or who cannot access the database, what are the rights we are giving for the authorization. Either the user can write, read, or it can do both. Data manipulation language. Language for accessing and manipulating the data organized by the appropriate data model. DML, also known as a query language. Two classes of language, pure and commercial. Pure is used for providing properties about computational power and for optimization like relational algebra, tuple relational calculus, and domain relational calculus. Commercial use in commercial system is SQL is most widely used in commercial system. Now we turn on to the SQL. The most widely used commercial language SQL. SQL is not a Turing machine equivalent language. SQL is not a Turing machine equivalent language. To be able to compute complex functions, SQL is usually embedded in some high-level language. There are front-end design and SQL runs in the backend. Application program generally accesses database-like extension to allow embedded SQL. Application program interfaces like ODBC, JDBC, which allow SQL queries to be sent to the database. Now we go on to the database design. The process of designing the general structure of the database. First one is logical design. Deciding on database schema. Database design requires that we find a good collection of relation schemas. Business decisions, what attributes should we record in the database. Computer science decisions, what relation schemas should we have and how should the attribute be distributed among the various relation schemas. Physical design, deciding on physical layout of the database. So this is the table that we are showing how database design can be performed. Design approaches. When the approach is good, then the database design will also be good. If the approach is wrong, then it will result in a wrong database. Need to come up with a methodology to ensure that each of the relation in the database is good. Two ways of doing so is that entity relationship model, or called the ER model in short. Models are enterprise as a collection of entities and relationship represented diagrammatically by an entity relationship diagram. When there is a relationship between two entities, it is called entity relationship. Normalization theory, when we reduce the anomalies in the database, and the process by which it is reduced can be termed as normalization theory. There are various normal forms like 1NF, 2NF, 3NF, and so on. Object relational database, when we focus on the object structure, class structure, that can be called as object relational database. Relational model, flat atomic values. Object relational data models extend the relational data model by including object orientation and constructs to deal with added data types. Allow attributes or tuples to have complex types, including non-atomic values such as nested relations. Preserve relational foundation, in particular the declarative access to data, while extending modeling power. XML, extensible markup language, defined by WWW Consortium W3C, originally intended as a document markup language, not a database language. The ability to specify a new tags and to create nested tag structure made XML a great way to exchange data, not just documents. XML has become the basis for all new generation data interchange formats. A wide variety of tools is available for parsing, browsing, and querying XML documents. Database engine, storage manager, query processing, and transaction manager. Storage manager. Storage management. Storage manager is a program module that provides the interface between the low-level data stored in the database and the application programs and queries submitted to the system. The storage manager is responsible to the following tasks: interaction with the OS file manager, efficient storing, retrieving, and updating of data. Issues: storage access, file organization, indexing, and hashing. So, when we access the database from the storage structure according to the application program, it is a very tough job. And how we simplify this process is an issue for storage access. File organization, how we are organizing the files and how we are indexing and hashing, that is a particular issues in the storage management. Now, query processing, how query is being inputted by the user and how it is being evaluated by the query engine. First one is parsing and translation, optimization, evaluation. So we are submitting query to the parser and translator or to the evaluation engine. Then we are putting relational algebra expression or SQL optimizer execution plan and have the statistics of the data. Alternative ways of evaluating a given query: equivalent expressions, different algorithm for each operations, cost difference between a good and a bad. Ways of evaluating a query can be enormous. Need to estimate the cost of operations, depends critically on statistical information about relations which the database must maintain. Need to estimate the statistics for intermediate results. Transaction management is concerned about when the system fails, how can recover from the failures. What if more than one user is concurrently updating the database? So this comes under the topic of concurrency problem. A transaction is a collection of operations that performs a logical functions in a database application. Transaction management component ensures that database remains a consistent, correct state despite system failures. Concurrency control manager controls the interactions among the concurrent transactions to ensure the consistency of the database. Database users and administrators. So these are the users like naive users, application programmers, sophisticated user, analysts, database administrators, and so on. Database system internals, you can see the how database structure is designed. Like first layer is naive users, application programmers. Second layer is application interfaces. Third layer is compiler and linker. Fourth is application program object code, then query evaluation, then buffer manager, file manager, etc., etc., and lastly we come to the storage structure. Database architecture. The architecture of database system is greatly influenced by the underlying computer system on which the database is running. Centralized, client server, parallel, distributed, etc., etc. So these are the history of database system, how database system has been developing since 1950 and how it has progressed to the modern times. So you can see this from slides, and thank you.